Good afternoon, guys. We are going to have a video for our notes today. Just wanted to make sure that you know that you're taking notes, focused note style. So you're going to take these home and annotate them and make revisions on them and summarize them and ask questions about them. Okay, and just so you know, you can always pause, you can replay, you can rewatch as many times as you need. Okay, so here's the title of our notes. It's 9.2, Data Distribution and Outliers. And the essential question is, what is an outlier? What statistics are affected by outliers? And what shapes can data distributions have? All right, and then some materials that we'll need are a calculator and scratch paper. All right, so let's get started here. We have some definitions first. We have a dot plot is a data representation that uses a number line and dots, X's, or other symbols to show frequency. Remember, which means how often. And dot plots are sometimes called line plots. And secondly, an outlier is a value in a data set that is much greater or much less than most of the other values in the data set. Okay, and remember, don't forget to pause if you need to. Okay? All right, guys, first, part one is going to be all about dot plots. Okay? To start off, we have 4 different examples of some dot plots. We have this one here about hours spent on homework, which uses dots. We have this one here about what people's favorite sports are, which uses X's. All right, so you can use a dot or an X, whichever one you would like. Okay, notice how this one uses dots, and this one over here uses X's as well. So it's totally up to you. However, every dot plot has to have that baseline on the bottom there, the number line that categorizes our different types of data. Okay, so we got to include that number line. All right. Okay, so example number 1. Create a dot plot for the accompanying data set. Okay, you see here a data set with our numbers. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total numbers in our sample. And we are going to, first, step 1, create a number line with an appropriate scale. Okay, so here we're going to choose the appropriate scale. When you guys do these on your own, you're going to have to draw it and figure out which appropriate scale would be best. Okay, so let's see here. I know I have a minimum of 25 and a maximum of 60 in my data set. So which scale here would be the most appropriate? Well, let's see. I'm going to choose this one here. Because this scale goes from 20 to 70, which is roughly the same numbers that I have here in my data set. I'm not going to use the first one because that one goes from 0 to 100, and I'm not going to use the third one because that one goes from 20 to 95, which would make our scale too long for the data set that we have. Okay, so pay close attention to the numbers that you have in your data set. Okay? All right, step 2, we are going to place a dot or an X above the number line each time that the number appears in the data set. Okay, so we'll start here with number 25. Cross it off so we don't mistake it. And I'm going to put a nice big dot above 25 on my number line. And I'll do the same thing for 30. Nice big dot. And here we have 1, 2, 3 35. So yeah, we're going to put 3 dots above the number 35. And we're going to be very careful. We're going to make sure that we space those dots evenly above each other. All right. And 1, 2, 3. We have 3 40s. And again, we're going to make those dots nice and evenly spaced. 1, 2, 3. And we're going to continue on with that process. All right. 1, 2 45s. 1, 2. There is a 50. And a 60. All right, so there you have it. There is our fully completed dot plot. And remember, if you want to use X's, that is okay. I like to use dots, so that's why I use dots. Okay? Now we're going to move on to part 2, which is calculating the outliers. Okay, now in order to calculate the outliers, we're going to use this formula here, but we're going to come back to that later. So don't worry about that just yet. We need to, again, in order to calculate these outliers, or data points that don't belong, you must calculate the IQR and Q1 and Q3 for the data set. Remember, IQR stands for the interquartile range, and Q1 and Q3 are the first and the third quartiles. Okay, so let's see here, we'll have our first example. All right, it's actually going to be the same example as our dot plot, except we're going to add the number 150 to it. Okay, so we're going to have the same numbers, and at the end, we tacked on that number 150. Now this would be our new dot plot, and as you see, we have this guy over here. Okay, that kind of looks like it doesn't belong with the rest of the dots over here, right? Okay, well, that means that 150 could possibly be an outlier. And here is how we find out for sure. We are going to use this formula here, which says x is less than Q1 minus 1.5 times the IQR. Or x is greater than Q3 plus 1.5 times the IQR. Okay, here's what that means. Well, we're going to find what Q1 is first. All right, in order to find what Q1 is, we have to first find the median of our data set. Okay, so we're going to cross off these numbers one by one. Awesome, which means our median is 40, and we're going to use that to find what Q1 is. So here we go. We have 1, 2, all right, well, Q1 is 35. And we're going to do the same thing over here on the right-hand side, all right? So we have we have two of them in there, so that means Q3 will be 45 plus 50 divided by 2. All right, so we have 45 plus 50 divided by 2, which means we have 95 divided by 2. And make sure you use your calculators, and that is going to give us 47.5 as Q3. So Q1 is 35, and Q3 is 47.5, which makes our IQR, that interquartile range, equal to 47.5 minus 35 for a final number of 12.5. All right, we're going to need those, all right? So we're going to remember those on our next slide. Q1 was 35, Q3 was 47.5, and the IQR was 12.5. Okay, we're going to use again this formula Q1 for the outliers, Q1 minus 1.5 times the IQR, and Q3 plus 1.5 times that IQR. Okay, let's work over here on this side first. Q1 is 35, so I'm going to plug in 35. My IQR is 12.5. Plug it in right there, and the rest will stay the same. All right, we're going to work on down. We're going to calculate that. So we have 35 minus 18.75 by using your calculator, 1.5 times 12.5, and we get a final total of 16.25. Okay? Now, as we look at our data set, there are no numbers that are less than 16.25. Therefore, on this side, there are no outliers. No outliers since since no number is less than 16.25. So there are no outliers on the left-hand side. Okay, let's repeat the process over here on the right-hand side using Q3 and the IQR. Okay, so we're going to have Q3, which is 47.5. And again, we're going to have plus 1.5 times that IQR, and that IQR is up here, 12.5. All right, so let's go ahead and use our calculator again. 47.5 plus, again, 1.5 times 12.5 is 18.75. And make sure that you all use your calculators here. And we're going to get 66.25 as our outlier boundary. Okay, do we have any numbers up here that are greater than 66.25? Yeah, we sure do, 150. So 150 is an outlier since 150 is greater than 66.25. Okay, so we have one outlier, and it is number 150, as we kind of predicted earlier in the slides. Okay? All right, and now for the final part of today's notes, part 3, comparing data distributions. A data distribution can have 3 shapes, and here are those 3 shapes: left skewed, symmetric, and right skewed. Okay, and now a data distribution, it describes how data is distributed, and again, it could be symmetric or skewed. Okay, so let's talk about the first type, symmetric. Symmetric skew happens, or no skew, I should say, symmetric or no skew happens when the mean and the median are the same numbers. Okay, and here's what that kind of a dot plot would look like. All right, what we do is we kind of trace it. Okay, notice how it looks pretty symmetrical. It looks pretty normal. Okay, that's going to be a symmetric curve. All right, now that is very different from something that is left skewed. As you can tell, if we were to trace this one, a lot different looking. Okay, we can tell something is left skewed by looking here. Okay, this guy here is called the tail, and when the tail is on the left, we know that it's left skewed. We can also tell that something is left skewed when the mean is greater than the median. Okay, and the last one that we're going to discuss today is when a distribution is right skewed, and you can tell that it is right skewed when it looks like this. And you notice here that now, that tail that I mentioned before, that tail is on the right. So the tail on the right, we get right skewed. The tail on the left, we get left skewed. No tails is symmetric. No tails. Okay? All right. And again, back to our right skewed, we can tell if it's right skewed when the mean is less than the median. All right? Thank you.